Assalamu alaikum, it's chapter 11, Parallel and Perpendicular Lines, part 3. The objectives is to calculate the coordinates of the midpoint of a segment, calculate the distance between 2 points knowing their coordinates. Prepare these materials. We will start with the midpoint of a segment. Given the points A of coordinates xa, ya, and B of coordinates xb, yb. The coordinates of the midpoint M is the midpoint of the segment AB, is given by xm, the abscissa of the point M, it is equal to xa plus xb over 2, and ym, the ordinate of the point M, it is equal to ya, the ordinate of point A, plus yb, the ordinate of point B, over 2. For example, given the points E of coordinates -2, -1, and F of coordinates 3, -7. Calculate the coordinates of the point K, the midpoint of the segment EF. Since K is the midpoint of the segment EF, we can follow the above rule. X of K, it is equal to, pay attention, we have the segment EF, it is equal to XE plus XF over 2. XE, it is equal to -2 plus 3 over 2 equal to 1 over 2. YK, also it is equal to YE plus YF over 2, which is equal to -1 plus into -7 over 2, which is equal to -8 over 2, which is equal to -4. So the coordinates of the point K are 1 over 2 -4. Application. In an orthonormal system of axes, x prime o x, y prime o y, consider the points A of coordinates -2, 3, B of coordinates 2, -1. Part 1, calculate the coordinates of the point M, the midpoint of AB. Part 2, calculate the slope of AB. Part 3, find the equation of the line D, the perpendicular bisector of AB. Pause this video and solve this application. In part 1, we must find the coordinates of the point M, which is the midpoint of AB. And since M is the midpoint of AB, so the coordinates of M is given by x of M, it is equal to xa plus xb over 2, which is equal to -2 plus 2 over 2, which is equal to 0. Y of M, it is equal to ya plus yb over 2 equal 3 plus into -1 over 2 equal to 2 over 2 equal to 1. Then the coordinates of the point M are 0, 1. In part 2, we must find the slope of the straight line AB. Also apply the rule of the slope. A of AB, it is equal to YB minus YA over XB minus XA. Pay attention here. YB, it is equal to -1 minus YA, it is equal to 3 over XB, it is equal to 2 minus into -2 equal to -4 over 4, which is equal to -1. In part 3, we must find the equation of the line D, which is the perpendicular bisector of AB. Since D is the perpendicular bisector of the segment AB, then we say that D is perpendicular to the straight line AB, and so the slope of the straight line D times the slope of AB, it is equal to -1. Then A of D and the slope AB, we find it in part 2, it is equal to A of D times -1 equal to -1 then the slope of D it is equal to -1 over -1, which is equal to 1. Now we find the slope. Also, the straight line D is the perpendicular bisector of the segment AB. And as we know, the perpendicular bisector cuts the segment AB in its midpoint. So, the point M belongs to the straight line D. M belongs to D, then we apply the relation y minus ym, it is equal to A of D into x minus xm. Here, y minus 1, it is equal to the slope of D, which is equal to 1, into x minus 0 to get y equal x plus 1, which is the equation of the straight line D. Distance between 2 points. Length of a segment. Given the points A of coordinate xa, ya, and B, xb, yb. In an orthonormal system, we can find the distance between the 2 points A and B, or the length of the segment AB. The distance between the 2 points, or the length of the segment AB, is given by the formula AB, the length AB, it is equal to square root of xb minus xa, pay attention here, square, we start with the point B, xb minus xa square, plus yb minus ya, all of it square. Example, given the points E of coordinates -2, -1, and F of coordinates 3, -7. Calculate the length EF. To find the length EF, we follow or apply the following formula. EF is equal to, we start with the point F, xf minus xe square plus yf minus ye square, all of it under the radical. It is equal to square root of 3 minus into -2 square plus -7 minus into -1 square. Pay attention here for the sign. 3 minus into -2, which is 3 plus 2 equal to 5, -7 minus into -7 plus 1, it is equal to -6, which is equal to 25 plus 36, it is equal to radical 61. So the length EF is equal to radical 61. Application 1. In an orthonormal system of axes, consider the points A of coordinates 2, -3, B of coordinates 4, 1, C of coordinates 1, 7, and the point D of coordinates -1, 3. Show that AB it is equal to CD. Pause this video and solve the application. To show that AB equal to CD, pay attention here, length AB equal to length CD. We must find the length AB and the length CD. AB it is equal to radical xb minus xa square plus yb minus ya square. It is equal to, substitute the coordinates of the points B and A, 4 minus 2 square plus 1 minus into -3 square, to get radical 20, which is equal to 2 radical 5. Also, CD it is equal to radical xd minus xc square plus yd minus yc square. Substitute the coordinates of the points C and D, and it is equal to radical 20, which is equal to 2 radical 5. Notice that the length AB, it is equal to the length CD, equal to 2 radical 5. Application 2, very important application. In an orthonormal system, consider the points M1, 7, E of coordinates 5, 1, and N of coordinates -1, -3. Part 1, show that the triangle MEN is right isosceles. Part 2, calculate the coordinates of I the center of the circle circumscribed about the triangle MEN. Pause the video and solve this application. Solution. Required to show triangle MEN is right isosceles. For that, we find the length of the three sides of the triangle. We start with ME, which is equal to radical XE minus XM square plus YE minus YM square. Substitute the coordinates of E and M to get radical 52, which is equal to 2 radical 13. Also, the length MN equal to radical XN minus XM all square plus YN minus YM all square, which is equal to radical 104 equal to 2 radical 26. Also, EN equal radical XN minus XE square plus YN minus YE square. Also, it is equal to radical 52, which is equal to 2 radical 30. Here, the three lengths of the sides are given of the triangle MEN. We try to apply the converse of Pythagoras theorem. ME square plus EN square, it is equal to 2 radical 13 square plus 2 radical 13 square, which is equal to 52 plus 52 equal 104. And here 104, it is equal to MN square. MN equal to radical 104, so MN square equal to 104. Now, by the converse of Pythagoras theorem, triangle EMN is right at E. Here the hypotenuse is MN, so it is right at E. Also, we notice that ME, it is equal to EN, equal to 2 radical 13. Therefore, triangle MEN is right isosceles. Part 2. Calculate the coordinates of I, the center of the circle circumscribed about triangle MEN. Remember that the center of the circle circumscribed, it is the circumcenter of the triangle MEN, and it is the intersection of the perpendicular bisector of the three sides of the triangle. In case of right triangle, the circumcenter is the midpoint of the hypotenuse. Here, MEN is right. Then, I is the midpoint of the hypotenuse MN. And since I is the midpoint of the segment MN, so we can find the coordinates of the point I. Here is the circle circumscribed about triangle MEN, and this is the point I, the midpoint of MN. So, xi, it is equal to xm plus xn over 2, equal to 1 plus into minus 1 over 2, which is equal to 0. And yi, it is equal to ym plus yn over 2, equal to 2. Here notice that the coordinates of the point I is 0, 2. Homework from the textbook exercises 8, 10, pages 149, 150. The summary: the coordinates of the midpoint M of AB is given by xm equal to xa plus xb over 2, and ym it is equal to ya plus yb over 2, and the distance between the 2 points, or the length of the segment AB. Thank you for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.